Sample questions. Sample 1. Find the HCF of 4052 and 12576. Let us apply the Euclid's division method. Dividend, divisor, multiply by quotient, plus remainder. Step 1. 12,576 is dividend. 4,052 is divisor. When quotient is 3, we get remainder 420. Step 2. 4,052 is dividend. 420 is divisor. When quotient is 9, we get remainder 272. Further simplification. 24 is dividend, 4 is divisor. When quotient is 6 and remainder is 0. HCF of 12,576 and 4,052 is 4. Solved using Euclid's division method. Sample 2. Show that every positive even integer is of the form 2q, and that every positive odd integer is of the form 2q plus 1, where q is some integer. Let a be any positive integer and b equals 2. Euclid's algorithm. A equals 2q plus r. For some integer q, possible remainder r equals 0, or r equals 1. Because r less than 2, a equals 2q for r equals 0, then a is even. Divisible by 2. A equals 2q plus 1. For r equals 1, then a is odd. A is of the form 2q. Then a is an even integer. A is of the form 2q plus 1. Then a is odd integer. Sample 3. Show that any positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is some integer. Rewrite the equation. A equals 4q plus r. Since 0 are less than 4, the possible remainders value for r are 0, 1, 2 and 3. When r equals 0, a equals 4q. Divisible by 2, so a is even. When r equals 1, r equals 4q plus 1. When r equals 2, r equals 4q plus 2. Divisible by 2, so a is even. When r equals 3, r equals 4q plus 3. Therefore, odd integer is of the form 4q plus 1, or 4q plus 3. Sample 4. A sweet seller has 420 Kaju barfis and 130 Badam barfis. She wants to stack them in such a way that each stack has the same number, and they take up the least area of the tray. What is the number of that can be placed in each stack for this purpose? Required solution. Each stack has the same number, and they take up the least area of the tray. Use Euclid's algorithm to find their HCF to the number of stack that has the same number. We have finding HCF leads to remainder 0 when divisor is 10, so the HCF of 420 and 130 is 10. Number on each tray. Sample 5. Consider the numbers where n is a natural number. Check whether there is any value of n for which ends with the digit 0. If the number 4 power n, for any n, were to end with the digit 0, then it would be divisible by 5. That is, the prime factorization of 4 power n would contain the prime 5. This is not possible because 4 power n equals 2 power n. Reason: the only prime in the factorization of 4 power n is 2. Sample 6. Find the LCM and HCF of 6 and 20 by the prime factorization method. By prime factorization, 6 equals 3 times 2, 20 equals 2 times 2 times 5. HCF, 6 and 20, equals 2. LCM, 6 and 20, equals 3 by 2 by 2 by 5 equals 60. Sample 7. Find the HCF of 96 and 404 by the prime factorization method. Hence, find their LCM. HCF, 96,404. The prime factorization of 96 and 404 gives 96 equals 2 power 5 3 power 1. 404 equals 2 power 2 101 power 1. HCF of these two integers is equals 2 power 2 equals 4. LCM 96. 404. LCM 96. 404 equals 2 power 3 and 3 power 1 and 101 power 1 equals 9696. Sample 8. Find the HCF and LCM of 6, 72 and 120. Using the prime factorization method. Prime factorization. 6 equals 2 power 1, 3 power 1. 72 equals 2 power 3, 3 power 2. 120 equals 2 power 3, 3 power 1, 5 power 1. HCF, 6. 72. 120 equals 2 times 3 equals 6. LCM, 6. 72. 120 equals 2 power 2, 3 power 2, 5 power 1 equals 360. Sample 9. Prove that square root 3 is irrational. Assume 3 is rational. If so, we can represent square root 3 equals a by b. So, b square root 3 equals a. Assume that a and b are coprime. b does not equal 0. Squaring on both sides. And rearranging. 3b square equals a square. Assume o equals 3c. For some integer c. Substituting for a, we get 3b power 2 equals 0.9c square. That is, b square equals 3c square. b square is divisible by 3. And so, b is also divisible by 3. A and b have at least 3 as a common factor. Contradicts the fact that a and b are coprime. Contradiction in our incorrect assumption that square root 3 is rational. Conclude that square root 3 is irrational. Sample 10. Show that 0.5 minus square root 3 is irrational. Method 1. Assume that 0.5 minus square root 3 is rational. 0.5 minus square root 3 equals a by b. Semicolon. Rearranging this equation, we get 0.5 minus a by b equals square root 3. 5b minus a by b equals square root 3. We get 5 minus a by b as rational. And so, square root 3 is rational. But this contradicts the fact that square root 3 is irrational. So, we conclude that 0.5 minus square root 3 is irrational. Thank you for watching Real Number Part -1. Register to join our channel for regular update. First option. Google Classroom. Use the URL as shown. Second option. Download Google Classroom from Play Store. Register for free. Google Classroom, class joining code S1WRHV. You will find links in the comment below. Cheers and good day.